In this video clip, we're going to continue our discussion of the mole, this method of counting objects by weighing them. And there's a flow chart that you can find in your Chem 2A text on page 247 or in your Chem 22 text on page 175 that sort of clearly outlines this process of how you use the concept of the mole to count objects by weighing them. If you know how many moles of a substance you have, and although it's not much of an abbreviation, the abbreviation for moles is MOL. Note that MOL never is an abbreviation for molecules, it's an abbreviation for moles. If you know moles of a substance, you can calculate the mass of substance present if you use the molar mass. In other words, the sum of all of the atoms or ions present in the chemical formula expressed in grams. Or if you know moles, you can calculate the number of objects you have present, atoms, molecules, ions, formula units, if you use Avogadro's number, 6.022 times 10 to the 23rd objects in a mole. And we can see that using this flow chart, we can basically start anywhere and end anywhere in the chart as long as we have the correct information, the molar mass and Avogadro's number. Let's illustrate with some examples. So here's our first example, and I have two parts included with it. So how many moles of carbon dioxide are present in 379 grams of carbon dioxide? So looking at this problem, I have given you a mass of carbon dioxide. I'm asking you to calculate moles of carbon dioxide present, and you need the molar mass to use as a conversion factor. Units, grams per mole. So before we go any further in the problem, we better calculate the molar mass of carbon dioxide. And we illustrated that when we calculated the formula mass of iron 3 carbonate. The molar mass is the formula mass expressed in grams. So looking at the formula of carbon dioxide, I see that 1 mole of carbon dioxide contains 1 mole of carbon. Periodic table tells me that the molar mass of carbon in grams is 12.01 grams, getting that right off of the periodic table. Periodic table tells me that the molar mass of oxygen is 16 to 4 sig figs, and there are 2 moles of oxygen present in 1 mole of carbon dioxide. So adding up these masses, I come up with a molar mass for carbon dioxide of 44.01 grams per mole. Note molar masses are always written per 1 mole of a substance. And now that I have this molar mass, I see that it is the relationship between the mass of a substance and the number of moles of that substance, and I can use it as a conversion factor. So I'm going to take the 379 grams of carbon dioxide, and I'm going to come and use this molar mass as a conversion factor. And the dimensional analysis is telling me that the gram unit in the molar mass needs to be in the denominator so that my units will cancel. So I'm going to take this molar mass and use it in its inverted or flipped form, which I'm doing here. I see the gram units cancel. I'm left with moles of carbon dioxide, and I can express the molar mass of carbon dioxide, I can express the moles of carbon dioxide as 8.61 moles of CO2 present in 379 grams of CO2. And it is always, whenever you're doing a calculation, a good job to just double check that value. So here I am double checking it and checking my sig figs. I see that I have 3 sig figs in this mass, 4 sig figs in the molar mass, so I'm expressing the moles of carbon dioxide to 3 sig figs. And now here's a second part to this calculation. Suppose I'm interested in just knowing about the moles of oxygen that are present in 379 grams of carbon dioxide. Suppose I want to focus on an element that's part of the overall compound. Well, I can see from the formula CO2 and from how I calculated the molar mass that 1 mole of carbon dioxide must have 2 moles of oxygen in it. In other words, the formula itself gives us mole-to-mole relationships between the elements and the compound that they are a part of. So I'm going to use that relationship that there are 2 moles of oxygen present in 1 mole of carbon dioxide that I see from the formula to solve this problem. So I'm going to take the 379 grams of CO2 that I used in my Part A calculation. I'm going to once again use the molar mass of carbon dioxide as a conversion factor. So if I stopped my calculation right here in the setup, using the molar mass in its flip form, I would get moles of CO2 as I did before. But I don't want to know about CO2. I want to know about oxygen atoms that are present in this mass of CO2. So I'm going to have one more conversion factor coming from the chemical formula that I used when I calculated the molar mass that says or states that there are 2 moles of oxygen present in 1 mole of carbon dioxide. Using this conversion factor, my moles of CO2 cancel, and I see that I have calculated moles of oxygen. So running through the calculation a second time to check my math here, I see that I have calculated 17.2 moles of oxygen atoms that are present in 379 grams of carbon dioxide. Let's do one more example before we finish this clip, and I'm going to use the substance iron 3 carbonate because I gave iron 3 carbonate as an illustration of how to calculate a formula mass. And if you recall, the formula mass of iron 3 carbonate, adding up 2 iron ions, 3 carbons atoms, 9 oxygen atoms, that formula mass was 291.7 AMUs. Well, we know that molar masses are formula masses expressed in grams, which is exactly what we saw here. We did a formula mass calculation using grams instead of AMUs. So I'm going to use that formula mass of iron 3 carbonate and just put the molar mass units of grams per mole. And looking at the calculation here, how many formula units of iron 3 carbonate are present in 4.2 times 10 to the second grams of iron 3 carbonate? Now again, formula units are kind of the equivalents of atoms or molecules, but we're talking about ionic compounds that consist of ions, not atoms or molecules. So we want to know with a formula unit, one formula unit contains 2 iron 3 ions and 3 carbonate ions, these little tiny packets of matter. So if there are very small numbers of ions present in a formula, in other words, if a formula unit is a very small number of ions, we're going to expect that a lot of formula units must be contained in 420 grams. So looking at the calculation, right, I have started out by giving you a mass amount, and now I'm asking you to determine number of objects, in this instance, formula units. So you're going to take the mass and first convert to moles in step 1 of the calculation, using the molar mass as a conversion factor. And then once you've calculated moles, you'll go on and calculate number of formula units using Avogadro's number as a conversion factor. So setting the problem up, Here is my starting mass of iron 3 carbonate. I'm using the molar mass as a conversion factor in its flipped form so that my units of grams will cancel. So if I stop the calculation right here, I just calculated moles of iron 3 carbonate. I'm right here on the flow chart, and now I need to calculate number of objects using Avogadro's number as a conversion factor. 6.022 times 10 to the 23rd formula units of iron 3 carbonate per 1 mole of iron 3 carbonate. So using this conversion factor, I see that my moles of iron 3 carbonate have canceled, and I have calculated the number of formula units. A very large number of formula units in 420 grams of iron 3 carbonate. So our final answer, if we go through the calculation, and I'm going to trust you to double check me with it, our final answer is 8.7 times 10 to the 23rd formula units of iron 3 carbonate that are present in 420 grams of iron 3 carbonate. Looking at the sig figs, 2 sig figs in this original starting mass, 4 sig figs in the molar mass, 4 sig figs in Avogadro's number. Our answer can have no more than the smallest number of sig figs used in the calculation, so we will report 8.7 times 10 to the 23rd formula units of iron 3 carbonate present in this sample.